Look up on a clear night, and the universe seems perfectly still. A quiet scatter of pale lights, unchanging, patient, calm. But that stillness is an illusion, a trick of distance and time. Out there, beyond the reach of the naked eye, the cosmos is anything but gentle. It is a place of unimaginable violence, of forces that could erase our entire world in a heartbeat. This is a tour of the most extreme objects ever discovered. We will travel to stars so vast they could swallow the solar system, to matter so dense a single spoonful outweighs a mountain, and to monsters where space and time simply come to an end. Hold on, the scale is about to get uncomfortable. Let's begin with size. Our sun is enormous. More than 1 million Earths would fit inside it. On any human scale, it is the very definition of big. And yet, among the stars, our sun is a barely visible speck. Far across the galaxy lies a dying red supergiant called Stephenson 218. It is the largest star we have ever found, with a radius around 2,000 times that of the sun. The numbers mean nothing until you picture it. If you placed Stephenson 2-18 where our sun now sits, its glowing surface would swallow Mercury, Venus, Earth, and Mars, and stretch almost all the way out to the orbit of Saturn. A jet airliner circling this star at cruising speed would need thousands of years to complete a single lap. Even light itself, the fastest thing in existence, takes hours just to cross it. Next to giants like this, our entire home is a grain of dust. But these titans live fast and die young. The bigger a star, the more furiously it burns through its fuel, and the more catastrophic its ending. For the largest stars, death is not a quiet fade. It is an explosion. When a massive star finally runs out of fuel, its core can no longer hold itself up. In a fraction of a second, it collapses inward, and then rebounds in the single most powerful blast in the known universe. We call it a supernova. The energy released in that instant is almost beyond comprehension. A supernova can shine 10 billion times brighter than the sun, pouring out more light in a few weeks than our star will radiate across its entire lifetime. For a brief window, one exploding star can outshine every other star in its galaxy combined. Hundreds of billions of suns, outblazed by a single dying point of light. Ancient astronomers watched these flares appear from nowhere and called them new stars. What remains is a ghost, a beautiful, expanding cloud of shredded stellar guts that glows for thousands of years. The Crab Nebula is one such wound in the sky, the wreckage of a star seen exploding back in the year 1054. And these explosions are also creators. The iron in your blood, the calcium in your bones, the oxygen filling your lungs, nearly every heavy atom in your body was forged inside a dying star and scattered by a blast exactly like this. You are, quite literally, made of supernova ash. But not everything is thrown outward. At the very center of that explosion, the crushed core can survive, and it becomes something that should not be possible. If it is heavy enough, gravity squeezes it into a neutron star. Imagine taking the entire mass of a sun and crushing it down until it fits inside a single city. A neutron star is only about 20 kilometers across, yet it holds more matter than our sun. It is the densest visible object we know of. How dense? A single teaspoon of neutron star material would weigh around 1 billion tons, heavier than every human being on Earth put together. Drop a marshmallow onto its surface, and it would strike with the force of an atomic bomb. Many of these corpses spin. As the giant core shrinks, it whirls faster and faster, like a figure skater pulling in their arms. Some rotate hundreds of times every second, sweeping beams of radiation across space like a cosmic lighthouse. We call these pulsars. The fastest known pulsar spins over 700 times every single second. Its equator is racing at nearly a quarter of the speed of light, a ball the size of a city, whirling so violently it is almost tearing itself apart. And then there are the magnetars, the most magnetic objects in all of existence. A single magnetar's field is trillions of times stronger than Earth's. Come within 1,000 kilometers, and it would pull the very atoms of your body apart, dissolving you before you ever felt a thing. A neutron star sits right at the edge of what matter can possibly withstand. But if the collapsing core is heavier still, nothing can halt the fall. Gravity wins completely, and the star vanishes behind a one-way door in space. It becomes a black hole. A black hole is a region where gravity has grown so intense that not even light can escape. Cross its boundary, the event horizon, and there is no coming back. No signal, no light, no escape at any speed. This is the ultimate point of no return. Fall in, and physics itself turns monstrous. The difference in gravity between your head and your feet would stretch you into a thin stream of atoms, a fate astronomers grimly nicknamed spaghettification. For decades, black holes were pure theory, invisible by definition, impossible to photograph. Then, in 2019, humanity did the impossible and captured the first real image of one, a black hole in the galaxy M87, 6.5 billion times the mass of the Sun. 3 years later, we turned the same eyes toward the heart of our own galaxy. There, hidden behind thick clouds of dust, sits Sagittarius A star, a black hole 4 million times the mass of the Sun. We have been quietly orbiting it this entire time. 4 million suns may sound like the ultimate monster. It isn't. At the center of nearly every large galaxy lurks a supermassive black hole, and some have grown to sizes that break the human imagination. When these giants feed, they become the brightest objects in the entire universe. Superheated gas spirals inward, glowing hotter than anything else in the sky, blasting out radiation across billions of light years. We call these blinding beacons quasars. A single quasar can outshine 10,000 galaxies at once. The most luminous one ever found blazes with the light of 500 trillion suns and swallows the equivalent of an entire sun every single day. At the deep end of the scale sits a titan named TON 618. This ultra-massive black hole holds tens of billions of times the mass of our sun, more than every star in the Milky Way combined, crushed into a single point. Its event horizon alone is wide enough to swallow our whole solar system many times over. If our sun were a grain of sand, TON 618 would be a sphere larger than a stadium. It is, as far as we know, one of the largest single objects in all of creation. Step back, and a strange pattern emerges. Every extreme object on this tour was born from the same quiet force we barely notice here on Earth: gravity, patient and relentless, pulling matter together across billions of years. Gravity built the giant stars. Gravity crushed their corpses into neutron stars, and gravity, taken to its absolute limit, tore actual holes in the fabric of reality. The gentlest force we know is also the architect of the most violent things that exist. And here is the humbling part. Everything you have just seen lies inside the observable universe, a bubble holding perhaps 2 trillion galaxies. We have explored only the faintest edge of it. Somewhere out there, in the dark between the galaxies, are objects stranger than anything on this list, waiting, spinning, collapsing, in total silence. The universe is not calm. It never was. We simply live far enough away to feel safe. If this journey to the edge of physics left you feeling a little smaller and a lot more curious, then you belong here. Subscribe to Ascent, and let's keep exploring the extremes of the cosmos, one impossible object at a time.